The maritime industry is facing increasing pressure to reduce emissions as regulators, such as the International Maritime Organization, IMO, and the European Union continue to implement increasingly stringent environmental regulations for zero emissions by 2050. To achieve this, the industry is exploring the possibility of moving away from traditional fossil fuels and towards cleaner, more sustainable alternatives. Among the alternative fuels being considered by the industry, ammonia is an attractive option. Ammonia is carbon-free and, when produced from renewable sources, offers a carbon-free path to reducing emissions. However, the introduction of ammonia poses significant challenges, mainly related to its toxicity, corrosiveness, and the need for robust safety protocols. Despite these obstacles, significant advances in engine technology, safety protocols, and infrastructure development are facilitating the introduction of ammonia. Ammonia-powered engines are being commercialized, and pilot projects for its bunkering and operation on ships are gaining momentum around the world. Long-term projections suggest that green ammonia could become the most cost-effective marine fuel by the end of the 2030s, playing a vital role in achieving a sustainable, carbon-free maritime future. The main advantage of ammonia is that it emits no CO2, sulfur, or particulate matter when burned. However, it is crucial that only green ammonia can deliver significant environmental benefits. Ammonia is abundant and can be produced using renewable energy sources such as wind and solar. It has high energy density and the energy potential to be a viable marine fuel. Ammonia has a lower volumetric efficiency and energy density than diesel fuel, meaning that a vessel using ammonia requires much larger fuel storage capacity. This impacts the volume and weight of the storage infrastructure, which also has a significant impact on the vessel's operating range. Although difficult to ignite, ammonia is flammable, creating an explosion risk when its concentration in air reaches 15 to 28% by volume. Combustion of ammonia can produce nitrogen oxides, NOx, and nitrous oxide, N2O. N2O has more than 200 times the global warming potential of carbon dioxide. Mitigation solutions and catalysts are being developed to manage these emissions. Man Energy Solutions and WinGD are methodically moving towards the commercialization of these massive prime movers, which will be the first to use carbon-free fuel. Wärtsilä introduced the first commercially available four-stroke ammonia-fueled marine solution in November 2023. The engines will initially be dual-fuel, using pilot fuels, e.g. biodiesel. Exmar LPG and CMB Tech has placed nearly 30 orders for XDFA engines for installation on bulk carriers, container ships, tankers, and LNG/ammonia carriers. The regulatory framework for the development of ammonia as a marine fuel is still being developed. IMO Guidelines CCS 10 IMO has completed the development of interim guidelines for the safety of ships using ammonia, with amendments to the IGC code on ammonia as a fuel, which are expected to enter into force on July 1, 2026. Ammonia is a very promising, albeit complex, alternative fuel for the decarbonization of the maritime industry. Its potential for zero-carbon combustion, especially if produced from renewable sources, is ideally aligned with global emission reduction goals. However, its inherent toxicity, lower energy density, and the need for significant infrastructure and regulatory development require a comprehensive and cautious approach. Subscribe to the channel